Good afternoon, everyone. My name is Jackson. I'm from the University of Melbourne. Today I'm going to talk about going hand in hand with JavaScript using the package RJS. So let's begin with the overview. So what does the package do? It lets R speaks to JavaScript so that you could create interactive and animated visualizations using JavaScript in R. And it's designed for experienced R users who are looking for just that a bit more flexibility in their data visualizations, and researchers or data scientists who are happy to outsource the visualization to the JavaScript, but still want to do the modeling in R, because that's where all the R packages live. So I've tagged out low-hanging fruits, and a little JS goes a long way there. So the spirit here is not to try to become a full-fledged JavaScript developer, but just to learn just enough to get the jobs done. So we'll go through 3 examples to see what are the possibilities and why it's a good idea to consider interactive app. So this example 1 is an interactive table replicated from this website. So here you have some buttons, and in the middle, once I click on these buttons, it will send a signal to R, and it will filter the data frames underlying this table, and it will compute summary statistics and display it at the bottom. So see, when we read about summary statistics, often we want to know how we are doing compared to our cohort, and how our cohort is doing compared to the entire populations. So if you look at the numbers of cohorts here, so numbers of combinations, we have 3 by 4 by 4 by 4 by 3 by 3. So we actually have 1,700 cohort here. So if I list 3 numbers for each cohort, I have to put down 5,000 numbers. Okay, so to address everyone, every cohort, that will be too much space, and it will be very hard to find. So that's why an interactive app could be useful in such a case. So the second example, replicate from this website, is the Berlin Marathon 2016. So when I click it, so you start. So these athletes will start to run. So on the left, this table, this number might be a bit small, but these are the finishing times. So at the bottom, you have the guy who finished last, and then 10% quartile, 20% quantile. All the way at the top is the person who finished first. So this app is meant to provide context to these numbers. By looking at this map, even non-marathon runners, like for example myself, could tell, say this guy is insanely fast compared to the rest. Yeah. So that's the first guy, and this is the 90% quantile. So this the person who beats 90% of people. So you see, these maps also give you a better sense how the distributions of the performance over the whole track and at all time. So I can scroll up like that. So for the so another point I want to make, actually you might already know how to make this. Okay, so if I show it in the R-based version, so this is the R-based version. So if you look at it, it's basically just a for loop with a plot function. So the reason we are not doing it, not because we do not know how to do it, we basically know how to do it. We are not doing it because R is a bit too slow, so for it to be useful. So if we replace that just R engine by something else, in this case JavaScript, then we will have access to these data visualizations facilities. Okay, so the last example is replicated from this website. It's digit recognition with GLM. So there's a canvas here where I can just draw digits, and you send these numbers to R, and it does classification real time and return all the results back. So I didn't draw it very well, so it's not very accurate. Let me redraw it. So 2, 71%. Okay. So it gives you a good platform to study the algorithm and try to understand what it's doing. For example, if I try to break it, say put a smiley face. Okay, so it's still 44%. Okay, well in a way it sort of makes sense, because if I connect these points, it does look like a 2, so it becomes 84%. So it gives you a platform to study and see how it breaks it. Okay. Also, you can use the same platform for different algorithms. I mean, like some of you might have gone to this deep learning thing tutorial earlier this week. Then you can also use this to compare between different methods. So each of the examples talks about 1 to 2 days, like full days, to do. And once you create them, well, you have created them, you can embed it in an R Markdown document, like what I did here. Okay, so how it works. So you need 5 commands. So let's start with the diagram. So on the left, you have R, and then you install this package, RJS. This RJS has some facility to help you build the HTML and the JavaScript. Okay, and once you build them, it will automatically insert this WS, which is the WebSocket for you. So once you have this set up, then let's say you click something on the JavaScript side, okay, and you get some data, which is in a list. To send it to R, well, you have this command, ws.send. Okay, then that information will send to R, and then you do some R package processing there, and comes back to, so that's the ws.on message. So this is the function that handles your message. So you can think of it as like a boomerang. So you throw a boomerang out, okay, and you expect to get something back because you want R to process the data and get it back the result. So it's like a boomerang, okay, comes back, you need a function that handles that processed message. And the third one is a ws.onOpen. So it's the function where you put the stuff to do when the connection is established. So it's usually used for initializations. So when the web page starts up, maybe there's some initializations of parameters you want to do, okay, then you use the third command. So 2 more commands, then we're done with all the 5 commands. So note that this channel actually can only take characters. So you transmit characters. So if we have a JavaScript data structure, say a JavaScript list, we have to turn it into character by using this json.string file. So it becomes make it a string, character string. And after it passes it to R, and it will become a named list in R and pass back as a named list. Once it reaches WS, you need to do the json.pass to pass the character back to a JavaScript list. So a good metaphor would be like if you want to send a letter, you want to put it in the envelope first. Okay, so the string file is like putting in the envelope, send it, and once you get the letter back, you open up the envelope. So it's the json.pass. Okay, so let's look at the R demo for a very simple example. So this is the basic structure of the program. So you load the library, you create HTML objects, and then you can look at it, what it is, and then start the app. Okay, so let's copy that and go to RStudio. Is it a bit too small? Look, let me change the font size. Why can't I just zoom in? Yes, I can zoom in. Okay, so if I run that, you will have a blank page here because there's nothing there, and you see the HTML object over here. So it's nice to learn some HTML as you learn how to use this package, because this will be useful in other cases too. Okay, and I can add a title to it using the add title functions, and add a slider using the add slider functions. It's starting to sound a bit silly. I'll just read off as it's typed. So you add a title, you add a text over there. So note that so the range, you have to input the range of the slider. So minimum 1, the maximum is 200, the default value is 1. You have to give an ID to it so that later you can use that value. And I put an empty box here for later use. So I also have to give an ID for later use. So let's copy that to R and look at the final results. So here we have the title, we have a slider that does nothing, and also have a title and an empty box. Okay, so that's the HTML down there. Okay, so since the slider doesn't do anything yet, so we want to add a new line here on input. So when I change the slider, send to R some value, this dot value. So this refers to the slider. Okay, once you move the slider, send this value to R. Okay, and then I add this JavaScript. Okay, I have to define, what do you mean by send to R? Okay, so I define these functions. So first I construct a JavaScript list. Okay, so in R style, let me do an R style. So R style, you will do, say, a list index equal to value. That's how you construct a list in R. So there's a very little syntactic difference. So for our message, it's an index colon value. Put a curly bracket there. After you construct that message, okay, put it in an envelope with json.string file and then send it over. Okay, so once R receives that message, okay, you write this R function to handle it. So first, this is a named list index up there, so I can take the $ of index Okay, make sure it's a number, so s.numeric. And then I can print it out and return the list again, construct another object and pass it back. So here basically I've done nothing. I just open it up and put it back together just to show you how you can use the data of the message. Okay, so once I finish the R processing and send it back to the website, okay, I need the WS on message that catch the boomerang. Okay, so we open up the envelope with the JSON.parse. So once you get the letter, open up and assign it to the data 0. And the last bit is a bit long, so it's at document dot, so it's your HTML dot get element by ID. So just now we have a text box with ID text box 1. So I just get that element, I change the inner text, and then assign it to be the data 0 dot index. Okay, so we have completed the entire trip from JavaScript to R and return. Okay, finally, I just need to put the R function there and put the server there. Then I have complete simple app here. So let's run that in RStudio. So now as I move it, I can see the value is printing. So it has reached R and it has been sending back to JavaScript. Okay, but there's nothing impressive here. So let's add a plot to it. So we have basically covered the most difficult part because the communication part is the most tricky. But actually, if you look at the JavaScript, we have only written down eight lines of JavaScript. Okay, so now let's add a plot to it. Okay, so to plot something, we need a data. So let's say I put a data 0. Let's say iris data set. Okay, what's inside that data set is not important. It's just a data frame. Okay, and that slider, I want it to control the row of that data. So when I slide that slider, I have this value. I want to extract the row of that data. Okay, and now I don't want to have this text box. I just want to plot functions. Okay, so so I add a JS library, the plotly.js library, and then I add a container with ID plot1, where I'm going to put that plotly plot into this container. Okay, so I also need to change the JavaScript correspondingly. So this line is the line that changed the text. Now I'm going to replace it by a makePlot function. So instead of changing the text box, now I just call a makePlot functions. And now I need to fill this in. So actually I didn't write that part myself. I copied from the plotly.js website because usually they have all the tutorial material. And that's also sort of the point of this package. Try to write, try not to write a code when you can just copy from somewhere. Just make the change you need and make it work. Okay, so let's copy this to RStudio. Let's run this. I forgot to stop the previous app, so okay, let's do it again. Okay, so the text box has been removed, and take away that. If I move the slider, now it reacts to, the plot reacts to my motions. So it's in a very smooth fashion. Okay, so how do we go from here? So you see, basically we have established the mechanism to handle the interaction between JavaScript and R. Now with just a little bit of massaging, okay. With a little bit of massaging, the app will look like something like this. Is it large enough? Oh, click the wrong button. Let's do it again. Okay, so this is not a huge difference from the app we had. Basically, I just add a text box up there, a text box on the right. Okay, forget about that button for now. And this is just your plotly plot we just saw associated with this slider. Okay, and once we build this sort of widgets, we can now replace the data. Okay, let's try another data set and get a new widget. Okay, it's the same layout. Okay, of course, you will have to type a new text too. So we have this sort of animated visualizations. Okay, let me show one more. So if I change another data set. So the point here is really you just spend time writing this widget once, and then you will reuse it many, many times. So this is the famous gapminder examples. So if you run that, again, it runs quite smoothly. Okay, so one key message here is that when you think about data visualizations, the magic is really in the data. You see, what I have done here is just changing the data with the same widgets. So once you have done all your data processing, yes, all the magic lies with the data, not exactly on the visualization bit. All right, so let's finish up. So as a summary, so RJS connects R to JS and brings in more flexible data visualizations. Okay, leverage existing JavaScript libraries so you can use any other framework to get more things done. So I hope we will get more better visualizations too for our packages and more good interactive tutorials, so something like the still.pub style. So this is an online journal that integrates interactive apps into the publications. And then creating more texting grounds for algorithms and datasets. Encourage more thinking about design. And the final bonus point, the JavaScript and HTML you learn as you use this package are all transferable. So in case, even if one day you don't use R and switch to something else, you can still use those knowledge. Especially now JavaScript has been quite popular, and you can use JavaScript to design Android app and desktop app, etc. Okay, so that's the end. So to get started, that's the REPL. And if you have a question, feel free to open a GitHub issue or PM me at the OpenSci Slack channel. Okay, thank you very much.
Any questions for Jackson? Does it do D3 as well?
Yes, it does D3 as well, yes. Actually, I have some examples on the REPL that uses D3. Sorry? Is it, well, basically, you can use any JavaScript libraries, yes. But I haven't tried the particular one you mentioned. Yes, yes. Yes.
When you deploy a Markdown HTML file to the web server, for instance, where's R? Where's R hiding at that point in time?
So it depends how you want to deploy it. So if you want to deploy it like a Shiny app, then basically you need an R server that lives behind it. Otherwise, you don't have that interactivity. And so for now, most of the things are done locally. Once I have sorted out the full implication, the full security implications of the deployment, then I will make it support that feature. Yes. Oh, yes. Yes.
That was a great talk. Thanks for that. So just where would you use RJS versus HTML widgets versus Shiny?
So so the question was, say again, what was the question?
So where would you, what cases would you use?
What cases would I use widgets and Shiny and RJS? So they are all designed for different use. For Shiny, I would say if you want something really quick and simple and easy to deploy, this is a well-established package already, you use Shiny. So HTTP with HTML widgets, if you have a JavaScript library that you want to commit to, then it's a good idea to wrap it into the HTML widgets, but it's not too easy to do. So it will take some time. So if you're committed to it, then you can do it. And RJS is basically, well, in my opinion, is anything other than that too. Then you use RJS. Yes. There's CRAN, yes. So I'm planning to first submit this to the OpenSci for review. If I can manage to get it passed, then I might make it to a CRAN. Yes.